The assertion that 15 amp circuits using number 14 American wire gauge wire are prohibited in commercial or industrial buildings but allowed in residential buildings is incorrect, according to the National Electrical Code. The National Electrical Code, commonly referred to as the NEC, establishes safety standards for electrical installations. These standards are intended to protect people and property from hazards that can arise from the use of electricity. The NEC addresses virtually every aspect of electrical wiring and equipment, providing comprehensive guidelines for safe installation and operation. Article 310.16 within the National Electrical Code provides the allowable capacities of insulated conductors rated up to and including 2000 volts, specifically those conductors installed in raceways, cables, or directly buried in earth, when operating at ambient temperatures not exceeding 30 degrees Celsius, which is equivalent to 86 degrees Fahrenheit. This particular section of the code is critical because it dictates the maximum current, measured in amps, that a conductor can safely carry without exceeding its insulation temperature rating. Number 14 American wire gauge copper wire, when used under the conditions specified in Article 310.16a, is typically rated for a maximum ampacity of 15 amps. This means that a circuit wired with number 14 American wire gauge copper wire can be protected by a 15 amp circuit breaker or fuse. The key point here is that Article 310.16 does not differentiate between residential, commercial, or industrial occupancies. The ampacity of a conductor is determined by its size, material, insulation type, and the environmental conditions in which it is installed, not by the type of building it is in. Therefore, a 15 amp circuit using number 14 American wire gauge wire is permissible in any of these occupancies, provided that all other relevant code requirements are met. There are, however, other factors that can influence the suitability of a 15 amp circuit with number 14 American wire gauge wire for a specific application. Firstly, the type of load that the circuit will serve is important. A 15 amp circuit is generally suitable for lighting small appliances and receptacle outlets that do not draw a large amount of current. However, it may not be adequate for equipment with high current demands, such as motors, heaters, or air conditioners. For these types of loads, a circuit with a higher ampacity and larger wire gauge may be required. Secondly, the National Electrical Code contains requirements for dedicated circuits for certain types of equipment. For example, a dedicated circuit may be required for a refrigerator, a laundry machine, or a bathroom receptacle outlet. The requirements for dedicated circuits are intended to prevent overloading of circuits and to ensure that essential equipment continues to operate even if other circuits are tripped. Thirdly, voltage drop is an important consideration in circuit design. Voltage drop refers to the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to operate inefficiently or to fail prematurely. The amount of voltage drop in a circuit depends on the length of the circuit, the size of the wire, and the amount of current flowing through the wire. The National Electrical Code recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. For long circuits, it may be necessary to use a larger wire gauge to minimize voltage drop. Fourthly, the presence of harmonics in the electrical system can also affect the suitability of a 15 amp circuit with number 14 American wire gauge wire. Harmonics are distortion of the voltage and current waveforms that can be caused by nonlinear loads, such as electronic equipment and variable frequency drives. Harmonics can increase the current flowing in a circuit, which can lead to overheating of the conductors and equipment. In situations where harmonics are present, it may be necessary to use a larger wire gauge or to install harmonic filters to mitigate the effects of the harmonics. Fifthly, the specific requirements of the local electrical code must also be considered. Local jurisdictions may have amendments or additions to the National Electrical Code that are specific to their area. These local requirements may affect the permissible uses of 15 amp circuits with number 14 American wire gauge wire. It is always important to consult with the local electrical inspector to ensure that all code requirements are met. Therefore, while the National Electrical Code permits the use of 15 amp circuits with number 14 American wire gauge wire in both residential and commercial or industrial buildings, there are a number of factors that must be considered to ensure that the circuit is safe and suitable for the intended application. These factors include the type of load, the requirements for dedicated circuits, voltage drop, the presence of harmonics, and the specific requirements of the local electrical code. A qualified electrician can assess these factors and determine the appropriate wiring configuration for a particular situation. In addition to Article 310.16a, several other sections of the National Electrical Code are relevant to the use of 15-amp circuits with number 14 American wire gauge wire. Article 210 covers branch circuits, which are the circuits that supply power to outlets and equipment. This article specifies the permissible uses of 15-amp circuits, as well as the requirements for overcurrent protection and grounding. Article 240 covers overcurrent protection, which includes circuit breakers and fuses. This article specifies the requirements for selecting and installing overcurrent protection devices to protect conductors and equipment from overloads and short circuits. Article 250 covers grounding and bonding, which are essential for electrical safety. This article specifies the requirements for grounding electrical systems and equipment to provide a path for fault current to return to the source, which helps to prevent electric shock and fire hazards. Article 300 covers wiring methods, which includes the requirements for installing conductors in raceways, cables, and other types of enclosures. This article specifies the requirements for protecting conductors from physical damage and environmental conditions. Article 400 covers flexible cords and cables, which are commonly used to connect portable appliances and equipment to electrical outlets. This article specifies the permissible uses of flexible cords and cables, as well as the requirements for ampacity and overcurrent protection. Article 430 covers motors and motor circuits, which are used to power a wide variety of equipment in commercial and industrial buildings. This article specifies the requirements for motor circuit conductors, overcurrent protection, and control equipment. Article 500 through 516 cover hazardous locations, which are areas where flammable gases, vapors, or dust may be present. These articles specify the special requirements for electrical equipment and wiring in hazardous locations to prevent explosions and fires. Furthermore, it is imperative to understand the concept of ampacity dating. Ampacity dating refers to reducing the allowable ampacity of a conductor to account for factors such as high ambient temperatures, multiple conductors in a raceway, or the presence of harmonics. The National Electrical Code provides tables and formulas for calculating ampacity dating factors. For example, if a conductor is installed in an area with a high ambient temperature, the allowable ampacity must be reduced to prevent the conductor from overheating. Similarly, if multiple conductors are installed in the same raceway, the allowable ampacity of each conductor must be reduced to prevent overheating. The presence of harmonics can also require ampacity dating. Harmonics can increase the current flowing in a conductor, which can lead to overheating. In situations where harmonics are present, it may be necessary to use a larger wire gauge or to install harmonic filters to mitigate the effects of the harmonics. Moreover, it is essential to perform proper voltage drop calculations to ensure that the voltage at the load is within acceptable limits. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to operate inefficiently or to fail prematurely. The amount of voltage drop in a circuit depends on the length of the circuit, the size of the wire, and the amount of current flowing through the wire. The National Electrical Code recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. For long circuits, it may be necessary to use a larger wire gauge to minimize voltage drop. Also, it is important to select the appropriate overcurrent protection device for the circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The overcurrent protection device must be sized appropriately for the ampacity of the conductor. If the overcurrent protection device is too large, it will not protect the conductor from overloads. If the overcurrent protection device is too small, it will trip unnecessarily. The National Electrical Code provides tables and formulas for selecting the appropriate overcurrent protection device for a particular circuit. Finally, grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to return to the source, which helps to prevent electric shock and fire hazards. Bonding ensures that all metal parts of the electrical system are electrically connected together, which helps to minimize the risk of electric shock. The National Electrical Code specifies the requirements for grounding and bonding electrical systems and equipment. In summary, the use of 15-amp circuits with number 14 American wire gauge wire is permitted in both residential and commercial or industrial buildings, provided that all applicable requirements of the National Electrical Code are met. These requirements include ampacity derating, voltage drop, overcurrent protection, and grounding and bonding. It is essential to consult with a qualified electrician to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. Proper electrical system design and installation are critical for ensuring the safety of people and property.